Hello students, I am Mrs. Anjali Nadgouda, lecturer, Department of Chemistry, KLS Gokte PU College of Commerce and Science, Belagavi. We are dealing with the unit number 1, some basic concepts of chemistry, and this is video number 4. Today we are dealing with uncertainty in measurement. In last class we have completed, that is seven fundamental basic quantities and their SI units. Okay, even we have seen some derived units and derived quantities. Okay, so when we are dealing with the measurement of all these quantities, we need some apparatus, is it? So these apparatus may vary, and because of that even the experimental data varies according to theoretical calculation or compared to theoretical calculations, right? So there remains always uncertainty. Uncertainty means which is not certain, okay, not sure, or there remains some error. And to deal with this experimental data or theoretical calculation, there are meaningful ways to handle the numbers, and one of such is nothing but scientific notation. Okay. As chemistry is the study of atoms and molecules which have extremely low masses and are present in large numbers. For example, for 2 gram of hydrogen gas, the mass is 6022, then 20 zeros on that number. See the number 6 0 the number is 6022, and how many zeros like this? 20 zeros. Okay, total 20 zeros. Then all of you have studied velocity of light, right? What is the value? It's 3. Am I right? What is the value? It's 3. Then how many zeros? 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8 zeros. Is it? Now, if such large numbers are there or 2 small numbers are there, then is it possible every time to write such number? Okay, it is very funny to write such numbers or to count the zeros, but when we are doing some mathematical operations on such numbers, it is very much difficult, or it is really a challenging role, is it? So to face this problem or to solve this problem, scientists have decided to write these numbers in small form, and that is called as scientific notation. So what is this scientific notation is? It is an exponential notation of writing too large means too much big number and too small means very small number, like 0 point, just say here 0.00000000, so total 24 zeros like this, and then one number like this. Okay, so such small numbers are written in the form of n into 10 to the power n, n into 10 to the power n, right, where capital N is a number which is also called as digit term, which varies between 1.0002, means these zeros can be extended, to 9.99999 can be extended. Okay. Now this number, it is 1 to 9. In short, we can say it is 1 to 9. Okay, that is less than 10. Into what, 10 to the power n or 10 to the exponent n. So n, small n is called as what? Exponent. Exponent may be positive or may be negative. Okay. So when we write in such form, it is called as scientific notation. Okay. Now how to write this number? So first of all, we have to convert the given number in the form of 1.000 to 9.999 in this form. Okay. Now if you observe this, it is 1. It is given as 1.000, means where is the decimal point? Decimal point is after first non-zero digit, or even in this 9.999, it is the decimal point is after first 9. Okay. So whenever we are converting the given number in scientific notation, the number capital N should be between 1 to 9. That is, if that number is having the decimal point, it should be shifted in such a way that it should come after first non-zero digit. Did you understand? Okay, we will solve some problems based on this. Okay, and we will see some examples. Right? Okay. So these are some examples. Express the following in scientific notation. Okay, let us solve the first one. 8008 is the given number. Okay, now how to write the such number in scientific notation? We have to convert this number in the form of n into 10 to the power n. Now small n is called as power or exponent. Okay, so let us see this. Now here n is given as 8008, which is 4-digit term, but we have to write it in this, in which form? 1.000 to 9.999. Is it in the same form? No. So how to convert this? So first of all, we have to see the decimal point. Okay, let us see the decimal point. Where is the decimal point? 8008. When you are writing this, the decimal point is, it is not shown, means after 8. Okay, so after that you can write many number of zeros as you want. Okay, but here it is not needed, right? We have to just find out where is the decimal point. Now to convert this into scientific notation, what we have to do? This decimal point, we have to shift it after first non-zero digit. Now which is non-zero? 1 to 9, all are non-zero digit, whereas 0 is 0 only. Okay. Now to shift this on the after the first non-zero, how many places we are shifting? 1, 2, 3 places we are shifting. Is it? Which side we are shifting? We are shifting on the left hand side. Okay. So whenever we are shifting the decimal point on the left hand side, the exponent term should be written as positive. Now how many places we are shifting? That is the number, that is small n. Okay. Did you understand? Yes. Now this number can be written as 8.008. Okay, into 10 to the power. Now what should be the power? As I said, we are shifting the decimal point 1, 2, 3 places. So it should be 3. Now which sign will come? It is plus. Why plus? Because we are shifting on the left hand side. Okay, so what is the answer now? 8.008 into 10 to the power plus 3. I hope you understood the example. Yes, we'll see the next one. Okay, so now the next number is 500. Okay, how to write now 500? Okay, 500 means where is the decimal point? Obviously after this 0. Okay, now we have to convert this into scientific notation. So what we can write? Now again we can shift this decimal point after first non-zero, that is after 5. Okay. So when we are writing this, we have to write 5.00 into 10 to the power. How many places we have shifted? 2 places. Which side we have shifted? Left hand side. So this should be positive. Okay. I hope, yes, did you understand? Okay. We'll go for next one. Okay. Now, the next one, third one, 0.0048. Now, if you observe the first two numbers, the decimal point is after that last digit. But here, the decimal point is before the digit. Is it? So, to convert such numbers, what we have to do? 0.0048, is it? So this decimal point, now we have to shift it after first non-zero digit. So which is the first non-zero digit here? 4. Okay. So how many places we are shifting? Count. 1, 2, 3 places we are shifting. But on which side we are shifting? It is on the right hand side. So exponent should be negative. Then how to write the number? 4.8, because we have shifted the decimal point, right? Into 10 to the power minus 3. Did you understand why we have given minus sign? Because we have shifted the decimal point on the right hand side. Okay. Yes. Now the next one, 6.0012. Now if you observe this number, 6.0012. Where is the decimal point? It is after the first non-zero digit. Means it is in the form of what? 1.000 to 9.999, but there is no exponent given, so we can write this as into 10 to the power 0. Why 10 to the power 0? Because anything raised to 0 is always considered as 1, and when we multiply by any number to 1, when we multiply by 1 to any number, the value remains same. Means there is no change in value at all. Okay. So what is the answer now? 6.0012 into 10 to the power 0. Okay. So I have given the answers also for this. I hope you understand, right? Okay. So these are the answers. Again you can try yourself, and in next slide I am giving exercise, that is some different numbers to convert this into scientific notation. Okay. So this is the exercise for you. Please write down in your notebook and try to solve this. Okay. You can refer the textbook also, or else you can refer any other book, or you can call if you have any doubt. Okay. Yes. So we'll go further for how to add or subtract or multiply or to divide these numbers. When we write any given number in scientific notation, how we can do the mathematical operation, that we will see in next slide. Okay. Yes. Let us start with addition and subtraction. So first we'll take the example of addition. Now such type of examples are given on the page number 9 of textbook. Okay, you can refer the textbook, but there is one small printing mistake that I will tell you later on. Okay. Now whenever I have solved the examples, I have taken the same numbers. Okay. So let us start with first 3.25 into 10 to the power 4 plus 2.45 into 10 to the power 3. Now whenever we are doing the addition or subtraction of scientific notations, Remember, there is a one rule, that is the exponent of the numbers should be same of the adding numbers. Okay, so first of all we have to make the exponent same for both the numbers or whichever given numbers are. Okay, so how to make? Now here the first step is, for addition or subtraction, exponent of the number should be same. Okay, so step 1 is making the exponent same, right? Now there are two different numbers are given. Okay, so for one number we will change the exponent. Okay, let us take 2.45 into 10 to the power 3 or 10 to the exponent 3. Okay, now this number we should convert it in the form of 10 to the power 4. Okay, 10 to the power 3 is converted into 10 to the power 4. Now to convert this, we must change the position of this decimal point. Now which side we have to choose, or which side we have to shift it? See here, we have to increase the exponent, means we have to shift the decimal point on the left hand side, and hence how we can change it? 2.45. When we shift this on the left hand side, one power will increase. Okay, so 10 to the power 3 into again 10 to the power 1. Okay, so it will become 10 to the power 4, right? Now here we are writing this number as what? Sorry, 2.45. 2.45, we are shifting the decimal point, means what we are writing? 0.245 into 10 to the power 1. Already 10 to the power 3 is there, means that number is also always again kept as it is. Now here the base is same, 10 to the power 1 and 10 to the power 3. Whenever the base is same and the multiplication sign is there, the exponent must be added. Okay, so what will be the answer? 0.245 into 10 to the power 4. Okay, so this number we have converted in the form of 10 to the power 4, right? Now the next step is, what is the next step? Addition. So when we are doing the addition, we have to add these two numbers togetherly. Okay, and 10 to the power is taken common. Okay, let us see how to do. 3.25 plus 0.245 into 10 to the power 4 is taken common. Okay, 10 to the power 4 is taken common. So what is the answer? Now this addition is done as usual, as you have done in your school age. Okay, I hope you know this. So 3.495 into 10 to the power 4. So one I will show you how to do. 3.25 plus 0.245. Okay, when we are adding these numbers, remember the decimal point should be taken one below 1. Okay, then nothing is there means 0. So 0 plus 5 is 5, 5 plus 4 is 9, 2 plus 2 is 4, then 3 plus 0 is 3. Okay, so the final answer is 3.495 into 10 to the power 4. I hope you understand the addition. Yes, the same addition can be done by changing the power of first number, 3.25 into 10 to the power 3. Okay, making it 3. So there is another way, it is shown in this. So again the same rule, making the exponent same. 3.25 into 10 to the power 4 is converted into 10 to the power 3. How it is converted? Now I have shifted the decimal point one place after this, means 3.25. Okay, this decimal point is shifted after this, so 1 will be less, the power will be less. So how we can write? 32.5 into 10 to the power 3. Is it? Okay, now again the same addition. Okay, that is taking the numbers one side, that is they are called as coefficients. So coefficients are taken one side and power is taken one side. Remember, here when you are writing the power, the number should be multiplied. Okay, this number 10 to the power should be multiplied because here the multiplication sign is there. Okay, so what is the final answer again? 32.245. 32.5 plus 2.45, it will come as 34.95 into 10 to the power 3. Again, this number is not a scientific notation, is it? So why it is not in scientific notation? Because the decimal point, the coefficient part, is not in the range of 1.0002 to 9.999. Am I right? So to convert that, we have to shift this decimal point between 3 and 4. Means one power will increase. Is it? So what is the final answer then? It will be same as like first one. So 3.495 into 10 to the power 4. Okay. Did you understand? Please see both the methods. The answer remains same. Okay. You can do by any one method. Right? Okay. Now the next example is of subtraction. Again the same numbers but only the powers are different. Okay, 10 to the power minus 3 and 10 to the power minus 4. So again the same rule for addition and subtraction, exponent of the number should be same. So making the exponent same. Now here we have to increase the power by 1. Okay, so 2.45. It should be converted into 10 to the power 4 minus 4 should be converted into minus 3, is it? So when we shift this decimal point, we will write it as what? 0.245 into 10 to the power plus 1. But already how much power is given for that number? 10 to the power minus 4. Now base is same, multiplication sign is there, so we can add the exponents. Minus 4 plus 1, it should be minus 3. Okay, and hence how we have written the number? 0.245 into 10 to the power minus 3. Okay, now the next step is same as like addition, that is subtraction. So 3.25 minus 0.245, is it? Into 10 to the power minus 3. So the final answer comes as 3.005. Okay, shall I show it? 3.25 minus 0.245. Now you can do the subtraction as your regular method, as you have learnt in your school. Okay, now nothing is there means 0. So this 0 we cannot subtract 5. So what we are taking? It is considered as 10. So 10 minus 5 is 5. Again that 10 is replaced, it is given back. So 4 plus 1 5, 5 minus 5 is 0, 2 minus 2 is 0 and 3 minus 0 is 3. So what is the answer? 3.005 into 10 to the power minus 3. Okay. So this is the way for subtraction. Same like addition. Okay. Only the condition is what? For addition or subtraction, exponent of the number should be same. Okay. Now let us see. The next example is multiplication. Okay. So 3.5 into 10 to the power 3 into 4.2 into 10 to the power 4. Now in multiplication and division, the rule is little bit different. Whatever powers are given, that is whatever exponents are given, we have to collect them together and add it. Okay. If the base is same, we can add the exponent. This rule is applied. So the steps are like this. Step 1, collecting the number, that is coefficients and exponent terms together. Okay. So 3.5 into 4.2 is taken in one bracket into 10 to the power 3 and 10 to the power 4. Here which sign is there? Multiplication sign is there. Remember, the base is 10. and multiplication sign is there. So whenever the base is same and when we are multiplying, the exponent should be added. Okay. So what will come the next step? 3.5. Next is multiplication. 3.5 into 4.2, it comes as 14.7 into 10 to the power 3 plus 4. So what is the next? Total it is 10 to the power 7. Okay. So this happens only in multiplication and division. Okay. Yes. Now again this number you can write the answer till here also, no problem. But if you want to convert this into scientific notation, okay, that is 14.7 into 10 to the power 7, right? We have to shift this decimal point after first non-zero digit. So 1.47. How many places we have shifted? One place. So 10 to the power 1 into 10 to the power 7 as it is. So 1 plus 7 again. It is 8. Okay, so here it is the small mistake. It should be 10 to the power 8. Okay, yes. Next one, multiplication and division. That is again the next with multiplication, but here the powers are taken as a negative. Okay, the same steps are followed. Collecting the numbers, coefficients together, 10 to the power minus 3 into 10 to the power minus 4. Then multiplication, again the same, 14.7. Now here 10 to the power minus 3 and minus 4. Both are having minus sign. So the 10 to the power exponent will come as minus. 3 plus 4 is 7. Okay. So 14.7 into 10 to the power minus 7. Again to convert it into scientific notation, we have to shift the decimal point 14.7. Is it? So this is shifted here. Left hand side means the power should be 1. Is it? Plus 1 and minus 7. 10 to the power minus 7. So minus 7 plus 1. It should be minus 6. And this is the final answer. Okay? Yes. Next, the last example, 3.5 into 10 to the power 3 divided by 4.2 into 10 to the power 4. Now again in division the same rule is applied like multiplication. 3.5 divided by 4.2, coefficient terms are taken together. Then this power is shifted to the numerator. That is this exponent 10 to the power 4 exponent is shifted on the numerator. When it is shifted from denominator to numerator, remember sign changes and the exponents are added. Okay, so here it is plus 4. So when it goes to the numerator, it will become minus 4. So 3 plus minus 4. Now whenever two such different signs are there, what we do? We are subtracting the smaller number from the greater number. Is it? So minus 4 plus 3 and we are giving the sign of that greater number. Minus 4 plus 3 will become what? Minus 1. Is it? 10 to the power minus 1. Am I right? So what is the answer? 0.833. 0.833 is the answer of this 3.5 divided by 4.2 into 10 to the power minus 1. Now again to convert this number into scientific notation, .833, right? This decimal point should be shifted after first non-zero, that is 8.33. Is it? But we are shifted on the right hand side. So what will be the power? 10 to the power minus 1. 1 again 10 to the power minus 1 is there. So minus 1 will become what? Minus 2. Right? Because base is same. So what is the final answer? 8.33 into 10 to the power minus 2. Okay, so this is how we have learned how to add, multiply or divide or subtract the numbers. Okay, now what is the small mistake is there, printing mistake on page number 9 is In second sum, 9.8 into 2.5 is taken in one bracket, and in another bracket 10 to the power minus 26 is taken. Instead of that, it should be minus 8. Okay, minus 2 minus plus minus 6, it should be 10 to the power minus 8. Okay, and it is given correctly in third step, so make that correction and we will stop it here only. Please revise again. Thank you.